Does reality exist when we're not looking? In quantum physics, particles exist in many states at once until you measure them. Can reality really work that way? Well, obviously it does. This is very, very strange. Live Science reports the standard interpretation of quantum mechanics places a lot of emphasis on the act of measurement, but before measurement, quantum systems exist in many states at once. After measurement, the system collapses into a specific one value, so it's natural to ask what's really going on when measurements don't take place. There isn't a clear answer, and different ideas can go in some really wild directions. One of the first lessons that physicists learned when they started examining subatomic systems in the early 20th century was that we do not live in a deterministic universe. In other words, we cannot precisely predict the outcome of every experiment. For example, if you shoot a beam of electrons through a magnetic field, half of the electrons will curve in one direction while the other half will curve in the opposite direction. While we can build mathematical descriptions of where the electrons go as a group, we can't say which direction each electron will take until we actually perform the experiment. In quantum physics, this is known as the superposition. For any experiment that can result in any random outcomes before we make a measurement, the system is said to be the superposition of all possible states simultaneously. When we make a measurement, the system collapses into a single state that we observe. The tools of quantum mechanics are there to make some sense out of this chaos. Instead of giving precise predictions of how a system will evolve, quantum mechanics tell us how superposition, which represents all the various outcomes, will evolve. When we make a measurement, quantum mechanics tells us the probabilities of getting one outcome over another. And that's it. Standard quantum mechanics is silent as to how this superposition actually works and how measurement does the job of collapsing the superposition to a single result. Schrodinger's cat. If we take this line of thinking to its logical conclusion, then measurements is the most important act in the universe. It transforms fuzzy probabilities into concrete results and changes an exotic quantum system into verifiable results that we can interpret with our senses. But what does that mean for quantum systems when we are not measuring them? What does the universe really look like? Does everything exist, but we are simply unaware of it? Or does it not really have a definite state until measurement takes place? Ironically, Erwin Schrödinger, one of the founders of quantum theory, it's his equation that tells us how the superposition will evolve in time, railed against this line of thinking. He developed his famous cat-in-a-box thought experiment, known as the Schrödinger cat, to show how ridiculous quantum mechanics was. Here's a highly simplified version. Put a live cat in a box, but also put in the box some sort of radioactive element that is tied to the release of a poisonous gas. It doesn't matter how you do it. The point is to introduce some ingredients of quantum uncertainty into the situation. If you wait a while, you won't know for sure if the element has decayed, so you won't know if the poison has been released, and thus if the cat is alive or dead. In a strict reading of quantum mechanics, the cat is neither alive nor dead at this stage. It exists in a quantum superposition of both alive and dead. Only when we open the box will we know for sure, and it's also the act of opening the box that allows the superposition to collapse and the cat to suddenly exist in one state or another. Schrödinger used this argument to express his astonishment that this could be a coherent theory of the universe. Are we really to believe that until we open the box that the cat does not really exist, at least in the normal sense that things are always definitely alive or dead, not both at the same time? To Schrödinger, this was too far, and he quit working on quantum mechanics shortly thereafter. Decoherence. One response to the bizarre state of affairs is to point out that the macroscopic world does not obey quantum mechanics. After all, quantum theory was developed to explain the subatomic world, but before we had experiments that revealed how atoms worked, we had no need for superposition, probabilities, measurements, or anything else quantum related. We just had normal physics. So it doesn't make sense to apply quantum rules where they don't belong. Niels Bohr, another founder of quantum mechanics, proposed the idea of decoherence to explain why subatomic systems obey quantum mechanics but microscopic systems do not. In this view, what we understand as quantum mechanics is true and complete for subatomic systems. In other words, things like superposition really do happen for tiny particles, but something like a cat in a box is most definitely not a subatomic system. The cat is made of trillions of individual particles, all constantly wiggling, colliding, and jostling. Every time two of those particles bump into each other and interact, we can use quantum mechanics to understand what goes on. But once 1,000 or 1,000,000,000 or 1,000,000,000,000 upon trillions of particles enter the mix, quantum mechanics loses its meaning or decoheres, and regular macroscopic physics takes its place. In this view, a single electron, but not a cat in a box, can exist in an exotic superposition. However, this theory does have limitations. Most important, we have no known mechanism for translating quantum mechanics into macroscopic physics, and we can't point to a specific scale or situation where the switch takes place. So even though it sounds good on paper, this model of decoherence does not have a lot of firm backing. So does reality exist when we're not looking? The ultimate answer is that it appears to be a matter of interpretation. This is by Paul Sutter, astrophysicist on Live Science. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box.